Hello guys, welcome back to Introduction to Go Programming video series. My name is Timothy. First of all, I'll start off with apologizing for being away for so long, and this video should have been released way earlier before now. And the first thing I'm going to do now is to complete the week 3 topics, which is going to I think we'll have left is channels and then sync mutexes. Yeah. So that's what I'm going to start off with. In the last video we treated the Goroutines. I showed you how we could use Goroutines to write some basic programs. Goroutines are quite powerful and they have a way of making your programs run really fast. And I have to tell you that in this video series I've not really covered some really complex things that can be done with Goroutines, since this is just an introductory class. So I also would not go into deep details with channels and what channels can do, what they cannot do, but I'm going to do my best to show you basic examples of what they are and how you can use them. And also I'm going to talk about sync mutex. I'm going to talk about mutexes. So yeah, I think that's all. Let's get started. All right. The last video I showed you guys this notes where channel is a communication mechanism that lets Goroutines send values to another Goroutine. So it's a basic communication mechanism, which is probably what makes a communication sequential processing possible in Go. So that is basically what the concept of CSP means. So channels makes this possible in Go. Okay, so in case you've forgotten what CSP means, so CSP is the concurrency model that the Go programming language uses. We talked about this in the last video, which I also showed you what this is all about. So channels are they are sort of the main guys that make this possible in Go. The main things that make this possible in Go. Okay, so let me jump right into showing you what channels and what you can do. So like I said, channels are basically communication mechanisms. So this is how you create a channel, and this is the same make function that we used to create maps in the past. So remember, this takes more parameters, which can be capacity. So we can actually set the capacity of what the channel will be, which basically limits the amount of data that can be sent through this channel. All right. And yeah, so let's write a very simple program that sends basically integer values through a channel, and then we're going to print it out on another side. Okay, so let me go ahead and uncomment this code, and then I'll walk you through it and show you what is actually happening. All right, so I'm going to save that. And all right, so all we have here is a Goroutine. So very simple stuff. Loops from 0 to 20 and then sends the values through into the channel, and we'll close the channel when we are done. All right, and down here we're going to loop through the channel and print out everything that is here. So actually, before we come down to this place, let me just do something very simple. So we could start by passing an information into a channel, and to do that we'll just use this less than and the dash sign. So we'll pass number 4 here, then we'll come down here and go ahead and print out what we have passed into the channel. So to retrieve data from a channel, we use the same symbol, which is basically a less than sign and a dash sign, as you can see. So I'm going to join that together, and you can save this program. Let's try running it. So say go run. Okay, we'll have a deadlock. And okay, so this is actually something that I was hoping to show you guys. As you can see, it's already happened here. So what this deadlock means is that we are trying the main Goroutine, or okay, sorry, just to prevent any confusion, I'm going to go ahead and fix this code, and show you guys exactly how this thing works before we get into that detail. So let's go ahead and say maybe 4, and can go ahead and assign that here, and going to print that out for save that. So we can run this code, and did I leave anything running somewhere? Give me a second. Okay. We're supposed to buffer this, so I'm going to go ahead and save that and run this code. Yes, so as you can see, we're able to print out the information that was passed into the channel. So, and yes, we can get rid of this. Yes, so this should also work. Another thing that we can do is we can also pass in different data type. So we can just do that one, and we can pass in anything. We can say go lang, save that, and then try running this code. As you can see, it prints it out. So basically we're sending in this data into our channel and we're printing it out here. This is a basic usage of a channel, and moving forward we're going to use this in a more complex way. So I'm going to go ahead and uncomment this code down here. So what this does is basically I'm going to change this one int, and I'm going to unbuffer it. All right, so so this is now an unbuffered channel. So what I mean by unbuffered is that there is no capacity. Remember, when this was like this is called a buffer channel, which means it has a capacity of 1, and we cannot send in data into that channel, cannot send more than 1 data into it. Okay, all right, so moving forward, we have a Goroutine. So what this Goroutine does is it starts off a for loop, and by the way, we have a for loop video, so if you still don't understand what for loops are in Go, please go ahead and have a look at that video. And yeah, all right, so we just loop through from 0 to 20 and send that integer value into our channel, and at the end of our loop go ahead and close the channel. So that is what this does. So this close function closes the channel, and everything is going to exit nicely. And after that we go ahead and use another range. So this is the type of for loop in Go that ranges through a channel and prints out every information that is being sent through the channel. All right, so before I run that code, note that we have 2 Goroutines at work here. So the first Goroutine is the main Goroutine. So the main function is run inside a Goroutine. Go does that on its own. Okay, so we have a second Goroutine which gets started when this program is executed. So, and this Goroutine starts a different routine, like a different thread, right? And then sends this information through this channel, and the main Goroutine is what's now reads through that channel and prints everything out. So once this close function is called, the main Goroutine will know that this channel has been closed here, so it exits the program. All right, so let's go ahead and run this code again, so you see what happens. And there we go, we have all our numbers printing out nicely. All right, so that's the first exercise. So the second one, we're going to be making use of a string. So I'm going to go ahead and comment out these guys, and I'm going to uncomment this. So this is basically this is similar to the integer channel. Sorry about that. So this is similar to what we have up here. So but the only difference is that we are passing in string values to our channel. All right, so we'll start by defining a sentence, and it's which we go ahead here and split into multiple words. So what this split does is it gives us a slice that contains all the words in our sentence. So it just breaks it into slices, and wherever there is space, which is what we specify here, because specify space, whenever it sees a space, it breaks it out into a new it breaks it into a slice. So I think we can go ahead and print this out so you guys will see what this does. Okay, all right. So the next thing we'll do here is we create a channel, and this is a buffered channel. As you can see, we are telling Go to create a channel that takes just the number of words that we have, just the number of words that we have in this array slice that was created here. Okay, so down here, just like we did up here, we are looping through you're looping through the words list or the words array slice, and we are sending it through our channel. Okay, so once we are done doing that, we can go ahead and close the channel, because we are done. And after that, we run another loop down here that prints out all the words inside the channel. Okay, so also know that we can even have another Goroutine somewhere that is not on this main thread, printing out all of these things as we send them through. Sorry about that. So let me go ahead and run this code. Yeah, so this is the list up here. So let me just go ahead and print this out and remove this print statement, so this is a bit clearer. Yeah, so we print each word as it comes out, add a space and print the next one. So we can even go ahead and add a comma here. Okay, so we're going to go ahead and say run this code again. As you can see, it's separated by commas, and yeah, this is just demonstrate basically what channels can do. So up here we sent in some information to the channel, and down here we're printing it out, and that's that. So moving on to the next thing, and okay, actually before that, let us try sending in another information after we've closed the channel and see what will happen. So if I save this and run this code, and yep, we're gonna panic. So once the channel closes, you can no longer send data through it, and that is why this is not working. All right, so yeah, that's it. So another thing is, if I decided not to close the channel here and move this thing down here, just so I can accommodate that, if I save this, run this code, and it still works fine. Yeah, so now let's assume that we have a Goroutine, maybe just like we did up here. So we did up here, so let's assume that we use the Goroutine to send this. Okay, oops. Yeah, so let's go ahead and use a Goroutine to loop through our words and then send it to our channel. Let's see what happens. Okay, everything still works well. Now if I brought this up here, I'll try running this, and the same thing happens. Everything is closed. Okay, so if I brought this out here, as you can see, nothing works. It just prints empty, just prints nothing, and panics because we try to send something down here when the channel is already closed. All right, so I advise you to actually go ahead and play around with this and see so many things that you can do and things that you cannot do, and understand why some of the mechanics of this, how the Goroutines works, and how channels are actually pass this data and do some more complex things spawn multiple goroutines. I mean, you can even come in here and use this for loop and create a goroutine at each time this is each time this loop runs, and see what happens. Okay, so this is something that we can do, and of course word doesn't exist in here, so we can actually pass this in here like this, VW. Yeah, so this makes it available in here. What? Hold on, what's happening here? Undefined W. Oh, string. Yeah, forgot to add the type there. So yeah, and all hell breaks loose. So this is one of the reasons why you should play around with this, because sometimes this can be really tricky. Because if you check out what happens here, we range through these words, send off these goroutines, and we close this channel. We are not waiting for these goroutines to actually complete sending this data to the channel. So when we close here, there's a goroutine that actually hasn't completed the sending, so it can, causes this to panic. All right, so yeah, go ahead and play around with this, and I'm going to take this thing back to the way it was before, so you guys can meet a working code on the repository. So take this back. Yeah, so that's it. Now on to the next one. Comment this out, and I'm going to bring this back here. And so right here we have a little bit more complex program, which basically generates goes ahead and generates this function. The generate function generates numbers and sends them through the channel. Okay, so as you can see, there is no condition, which means this is practically an infinite loop, so this loop never ever ends. Okay, so now as this number is being generated, we have another function down here, which is the filter function. It takes two channels, it takes an input and an output channel, and they both accept an integer. Okay, and this function also takes in a prime parameter, and basically what it does is we get the input, get data, or we get a number from the input channel, and then we divide it by the prime number. Okay, and sorry, this is modulus, so we get the modulus. If it's perfectly dividable by the prime, we'll send it through the output channel, which we're going to now loop through and print out information as it goes in. Okay, so back to the main program. As you can see, we basically have three goroutines working here. So the main goroutine, the goroutine that runs our generate function, and another goroutine that filters it. Okay, so we, in a different language, we're going to call these threads, but they're not threads, but we basically have three different threads, all right, executing this one program. So as you can imagine, this is going to be faster than some languages, because we have three threads or three goroutines working on the same program. Okay, so now what's happening here is we have another infinite loop. So this is meant to loop through the channels. Okay, so this loop through the channel, and I think this channel, let me go ahead and rename this so it makes sense. So this is our input channel. All right, yeah, this should be the input channel. So our input channel here, and we'll call this in, and then we're going to create an output channel here. So it's an output channel. All right, so now we'll create an input channel. So this channel is where data generated is passed into. All right, and we'll also, let me quickly write this in here. All right. So we pass the input channel into the generate function, and it sends in this data continuously into this channel. So the first thing we do here is we retrieve data from that channel, which becomes a prime number. All right. Now I'll print the prime number, the prime itself. All right. Now we create another channel, which is the output. This is where we want this data to be sent into. Sorry, this is where we filter the the prime. That is what I showed you earlier, which is we do basic calculation and send the number back into the output channel if it is divisible, if the number is perfectly divisible by the prime number. Okay, so the generates these prime numbers for us, right? And then the filters them out and prints them up here should they work. Okay, so we print this out, creates the output channel, and then we filter this out. And down here what we're doing is we go ahead and reassign. So we are changing this input channel. So we're changing the input into the output channel that was created here. So as you can see, at every iteration of this loop, we're creating a new channel. Okay, so what we just do is we just go ahead and replace that channel with this. Okay, so this helps prevent what we call a deadlock. So a deadlock is when we have a channel that never ever closes. All right, so a deadlock happens when we have a channel that never ever closes. There are multiple reasons why a deadlock would happen, and I wouldn't talk too much about that. You can feel free to check that out online. And so this is one technique to prevent deadlock from happening in our program. Okay, so you can go ahead and execute this program, and as you can see, it's an infinite loop. So we just continues to print out the primes as expected. All right, so that's that for channels. One final thing I would like to talk about is the mutexes. So the mutex is another pattern of concurrent programming, and this is provided us by the sync package. Okay, so you can see here, and the sync package comes with what we call mutexes. So mutexes is a form of concurrent, or let me not say form of, but it gives us the ability to safely share data across multiple contexts. Okay, so it's a basic lock and unlock mechanism that is, added onto data, right? And if you look at the example that we have here, we have a map, and this map just has states, and this program just does what we call read and write operations. And basically, before each read operation, we lock the data itself. All right, so now the fact that we started up 100, this program started about 100 Goroutines, so you can see here, and there's a lot of Goroutines that has access to this state data here. All right, so this can be a problem if you have a lot of different processes trying to access the same data. I mentioned this during my concurrency videos where I was talking about thread safety and all that stuff, and how using channels to communicate instead of sharing memory across all those contexts is much better way to go about this. So, but mutex locks is another way of doing it, and I've seen this used a lot in other programming languages that don't have a communication mechanism. So what they basically do is they lock the states. So that's what happens here. So you lock the states, and then you can mutate, and then you unlock it. So unlocking now gives other Goroutines access. So when a Goroutine tries to access this information, so maybe it's trying to write like down here, or even to read from it, it's going to get a lock to that state. All right, it can be any data actually, it can be a struct, it can be anything at all. So once you lock that data, it goes ahead and edits it, reads or writes to it, and then unlocks it for another Goroutine. Okay, so this is basically what will happen. Lock it, read, unlock it down here, lock, write to it. As you can see, we are assigning a value here. That's why it's a write, and then we unlock it, and then we'll sleep for 1 millisecond, and program continues. So yeah, basically this is that's what mutexes are. I don't expect you to fully grasp this from now, but I advise you to take a while, play around with all of these things and read more about it. And I'm going to recommend a Go programming book, so which you can also walk through and get a better understanding of all these concepts. Okay, I think that's that for this video, and in the next video I'm going to move on to talk about HTTP and a bit about testing, benchmarking, and also writing a documentation. See you then.